Good afternoon, all. Um, that's just turned 1 o'clock, and I think that's most people back in from lunch now. Hope you can all hear me. Um, yes, Miriam and Jaime, if you can hear me, you can give me a wee shout out. But we can get started into the next session. This last bit is going to be looking at how to use a Shiny app in public health research. And I'm going to be starting off with looking a bit about how a Shiny app is put together, what it means, how it functions, and hopefully show that you can do this too. And then Jaime will run us through some examples of how you start to build a Shiny app and how to debug it as you go. Now, it might seem a bit of a confusing term or a bit of a high-minded term, public health researchers and apps. I don't think we always think of them as the first place to go to. So what exactly is a Shiny app? Well, 1 minute, change screen. Yep. Shiny itself is a package that's going to make an interactive website for you out of your R work and your R data. It translates R code into web code. So it works as HTML, CSS, and JavaScript put together. But the good news is you don't need to know anything about any of those languages to create a Shiny app. R is going to do all of that for you. It builds your app as an interactive web page that can do lots of things in it. And we'll have a look at what can be got away with there. Why might you use Shiny? Well, first of all, Shiny apps are free to develop and deploy. There are paid options if you're anticipating a lot of users, but generally they're quite free to use locally and to share around team members and to publish publicly as well. There's plenty of free options out there. There's a lot of flexibility and potential for Shiny apps. Anything that you can do in R, or almost anything you can do in R, can be translated to be done in a Shiny app and can be done interactively through a web browser and viewed by anyone and manipulated by anyone. Anything R can do, Shiny can do more flexibly, which is not the snappiest of slogans I've come up with, but you see what I mean. Anything that R can do can be translated. You might use it for teamwork, for example. You might have members of your team who are specialists in other areas and you need to talk them through your analysis, how you chose the parameters you did, how to share your data and communicate the level of confidence you have in your outcomes and all of the sensitivity tests you could do in this data. You can use it for public engagement as well, showing how an analysis works and why it can be trusted upon to provide a level of confidence in your work, talking people through it as you go. And it's also very good for reproducibility and open research. If you publish a Shiny app that you are using to do all of your analysis, for example, then that is fully open. Anyone without even having any training in R can then take your Shiny app, rerun your analyses, tweak things and see if they can find any fault with what you've done, which is a frightening thing maybe, but hopefully something that shows us a pathway to an open research and reproducibility environment. There might be a few drawbacks. This is another new thing, potentially a new skill to have to take on, a new thing for your organization to have to come to terms with. So that's balancing the cost of when you're starting into this. It's also easy to use for public-facing data, stuff that's already published online, but not as easy for confidential information because in theory you're making all the data that the app is using publicly available. That might not be, if you're following the same guidelines and procedures as open access data, then hopefully you'll be able to come up with something that is shareable in the same way a published paper and its data is shareable, but just something to bear in mind as you're doing it. It also takes a little bit of time for development as you're trying to debug and style it and make it work precisely. There's a few differences between a Shiny app and normal R code. Firstly, it's split into 3 parts, whereas in R you might have one script which is running all your analyses one after another. In the Shiny app, you need to divide it up a little bit. Global, that's quite a general term for things that's available all around the app. It's an environment in some ways. And the key 2 parts we'll look at today are UI and server. Your user interface, which is building the user-facing screen that you're going to give them, and the server that's going to do all of the work for you. And we'll talk about how they interact and how you build each of those. Secondly, this reacts live to user input. As you change a variable, as you change any parts of what you want to put into your analysis, it will automatically update everything and pop out at the other end. And you don't need to press the run button every time. You don't need to search through your code for where you have to change your X, Y's, and Z's. You can present it to your user as, do you want to change this variable? So it's very reactive, very interactive. You have the ability to integrate the CSS, HTML, and JavaScript web languages. As I say, you don't need to know any of them to use a Shiny app properly, but if you or other people on your team have specialities in these areas, it's very easy to get into the app, use them to hack around in the background, change the appearance of your app, add features that haven't been invented yet, or just understand how it's all been put together. And fourthly, the structure of the app and running order of the code is slightly different from normal R code. Just to give a little bit of a visual of what we're going to produce when we make a Shiny app, I'll just show you the example one that comes with RStudio. As you open up RStudio, hopefully you can all see the right screen there. Flag up if you can't. So my RStudio window, if I wanted to create a Shiny app, the easiest way to do this, of course, is new file, Shiny web app. I'm going to call this one test, just to give an example of it. And you'll see here that it's asking if I want a single or multiple file. I'm going to choose this option. Jaime will run through the other one of how you run an app in a single file. This is going to create the two files, our user interface file and our server. Just to show you what that looks like, we won't run through the content of this just yet. We're going to create two files, UI and server, and R is going to work out how to use them together. You notice the Run App button has now appeared, and when you click that, it will read these two files and put them together into a working interactive app. So this is the easy standard one, very simple inputs and outputs. And what we're going to do in the next hour is look at how we then replace these things and muck around with these things and style them a little bit to make exactly what we need to output to our users. So that's the classic example one. Let's flick back to here. So the key building blocks, as we say, are two things, the user interface and the server. And the thing to have in your mind as you're building these two things is how things are passed between the two. Your user interface, as I say, is creating an interactive screen in a web browser, and that is passing things to and from the server. The user interface takes an input, input A it calls it, we'll work out how that works in a second, passes it to the server file, who takes this input, processes it using all the code that you're writing, and then creates an output and then passes it back to the user interface. In all the slides that we're looking at, hopefully you can see that's divided up. The server is almost a black box, but I colored it green here to make it slightly more visible to us. The users can't see what's going on in here, but this has been designed by you to run all your R code, and then this is what's being presented to them. So everything you're doing is crossing this divide to go into the R code and crossing it to come back out. Pause there just in case there's any questions have come up so far about this.
Nope, not at the moment.
I was hoping there would be, so I could take a longer sip of coffee, but that's fine. Great. So then how do you start putting these bits together? The first key thing, I'm probably going to skip forward a few slides there by accident. Okay, yes, structuring the user interface. In your UI.R file, you might have got a quick sneaky peek of it in the other bit there, but you're using your R code to build this structured page, and it works as like a normal web page. In the web page output, you'll have, see, a title, your inputs are going to go into a sidebar, and your outputs into a main part. It doesn't have to be this way, but that's a helpful visual for how you're presenting it to your users. And the UI.R file is going to build this for us, and you'll hopefully see that the way it does this is, as all these functions are nested within each other, this is how it nests the page. So the fluid page is everything that's contained within this function as part of the whole page. Anything contained in the title panel appears here. and then in the sidebar layout is contained within this bit, and within each part then you can put more elements, subdivide, and structure it all together. So anything you put in the code in the UI.R file will appear in exactly that place in the user interface when it's rendered. The things that are available to you then to build a user interface. First of all, you want your input functions, and what do these look like? There's, well, one other thing I should quickly point out while I remember that this is functions nested in functions, and everything that's passed to a function as an argument is separated by commas. And this is going to be the biggest nuisance with how you're debugging your code. You'll see there's going to be commas everywhere. So we'll have a look at that in the apps later on, but just as a helpful hint to keep in your mind as you build it. Do you see a question come up there? Sorry.
Yeah, there's one question around, so it says, for those of us that don't have access to R version 4, has anything changed in Shiny that we should be aware in your examples?
Oh, so, so there shouldn't be anything that's changed at all between older versions of R and the latest version of R. Yes, thank you for pointing out. I've only just updated it and gone through all the headache of reinstalling all my packages, but it will work absolutely fine if you do the same installations. I think all the way back to R. I'm not going to make any promises, but R version 3.2 or something. And if they have helpfully kept all of these old versions still active. Great.
And there's another one. The line was breaking. Can you please say again about the 3 dots? Thanks.
Oh yes, the 3 dots. That's just to illustrate that there's things going on there. That each of these is going to be an element we want to stack inside this part of the. So in this green box called outputs that we're going to call it, anything we want to put in there is going to be stacked on top of each other. This might say put a graph here, then some text, then a table, then another graph. We'll see how those stack up and build and how you can change the layouts of it a little bit there. Yes, that's hopefully a helpful placeholder for the things we might want to dream up that we can put in. So to start with things that can be put into the app, first of all, we want our input functions to allow our user to start to put stuff in. And here's a few examples. There's a few more aside from this. Your text inputs, that's going to create on your page a text box that passes a string to the server. So anything that's entered in here will become a string variable in the server. Your checkbox input will become a logical numeric input to numeric. And these two for giving them a pre-set selection of choices that they can put into the app. And this will pass a string of their chosen option. So these are a few inputs. I'm going to flick over to R just very briefly to show in a wee example app we've put together that show how these get rendered. You'll find this in a session 2 example. We want to open both these files, server and user interface. And once it's open both, you'll hopefully see, now I've laid them out a little bit to hopefully see how this is, again, a nested thing. The fluid page is containing everything. Your title panel is going to contain your title. We'll see how that's rendered in a second. Then in the sidebar layout, what we want to look at is the contents of the sidebar here. And this is how you'd put in each of the elements that you need. You've got your text input, and that's going to have an input ID, the label you want to put above it, and the value. As I say, comma after it to make sure you put in the next value there. Checkbox input, date input, numeric input, radio button, select input. As we click run app on this one, we'll see how it all puts together. We'll see what this is doing. Of course, it's running. This is zooming in as well a little bit. The output is coming somewhere underneath. This is stacking up each element that we've put in this sidebar panel in the order we put it in and giving us exactly what we've asked it for. You can see the labels are telling the user what's got to be put in everywhere. Some some of them take a value to start with, and the value gives you a default value and the choices. So that's how your input is going to look as you ask your user, what do you want to chop and change about this? To flick back here, you can always find a helpful cheat sheet at ShinyRStudio.com. It gives you a whole list of different input options that you can access and use, and all the things that are going to be able to output to give your app for further control. So that's a helpful thing to know about, that you can tweak and choose from each of these ones on how to use them a bit. Output functions. You've got a few of these to look at as well. The secret about an output function is that, first of all, it needs rendered in the server file, then outputted in the user input. And what you'll find is that every single one of these render functions that you use in server corresponds quite nicely to the output function here. So you're telling it to render text to output a text output, render plot, output a plot output, and render data table to output a data table. The key for passing things between the user interface and the server, I should probably skip back a wee slide actually, just remember that this is the same for the input, is that for each of these, this is creating an object called input $ID in the server. And the same for the output, is creating, you assign this to output $X in server, will then do output ID X in the user interface. We'll look at that kind of a bit more detail in a wee second. But that's how you're passing things to and fro. You create all the plot you want to render as a plot, send it to the output, and then the output file will output it here. 1 second, I think I'm seeing some questions flashing up. Actually, if I'll just quickly show you how that looks in the Shiny app again. So we've seen now the inputs work, how they stack. Then looking at the main panel, oh, didn't mean to zoom that bit out. We've got a couple of outputs here: a plot output of a distribution plot, a dot plot, and data. And when we go back in and run if it's already running, we will see that that's what's being created here. And these bits are being stacked, and this bit's been put in a new column. But the plots are being rendered, and the table's being rendered. So that's the kind of basic layout of how the user interface is working and how it's putting stuff together in the page. Do you have some questions to take there? Maybe some things to clarify?
No, nothing.
Okay, that's fine. Going back then, so we can see how we use these input and output objects in our user interface. When we're passing it to the server to be processed, there's a few key things we need to take in mind about how the server receives all the inputs and processes them and spits them to the outputs. We'd seen that input, so in type, that might be text input, checkbox input, etc. It's taking an input, it's giving it the label input ID equals probably something more informative than that, but this is just a placeholder here. When the browser is given a value here, that passes it over to the server, which is accessible through this object, input A. You see it's what's in quotation marks here then becomes a named object as part of the input object itself. The server can take that, if it's a string file or a number or anything, input it into any functions and processings you need to do in your server. It renders an out type, such as a graph, and assigns that to output X, which then gets outputted. And again, you see out type, use the same term there, plot, text, whichever one you're using, and your output ID then reads whatever's gone to X here. The key thing to note about all of this is all reactive. Whenever something gets updated in the user interface and the value of input ID A changes, that's sending then a signal to the server to say change everything that depends on A. And as soon as the server has done that, it sends a message to the user interface to change the plots and everything that's being rendered and put back out. You'll have some non-reactive parts, some static parts of your app, and that's usually included in the global part of it. If you're reading in the data, for example, that doesn't need to be reactive. You can have a static data set, in all likelihood, that is then getting manipulated by the interactive functions. So that's not included in the reactive bit. It's in your app. But each of this bit is reactive and updates automatically. If you've got more than one input, it's easy enough to feed those straight forward into the same functions wherever you are in your server. And this imaginary function called func, just taking all the inputs that you want to put into it and rendering the same out type, and that's super simple. We'll pop over to R to kind of see how that's working in the app itself. Zoom into this a little bit. So again, remember we've got our sidebar panel with all our inputs, and now you will see that each of them is being assigned an attribute called input ID. So that's checkbox input, CI, date, bins, call, comparator. Each of these is going to be then accessed by the server using this same structure here. So input date is taking the date variable from your date input and putting it into this function here. And that's just rendering the text that's going to be put to our title analysis on the date that you input. Another one might be so for your plot that you're outputting, you want your comparator in your plot to be chosen from the comparator selection boxes here. You also want to maybe change your title, take a text input, call it title, and put it here. And all that's going to go into this dist plot output, update it automatically. Remember, render as a plot, render plot, and output this dist plot as in a plot output here. So that's the kind of the whole life cycle of data and interactivity going in and coming back out. And as you see, that then becomes in the app itself something that's super quick to update. So this one's called comparing cars at the minute. We want to change the title. We want to call it histogram or something. Histogarm. That was terrible spelling. And you see it straight away. It's already put the right thing in. Want to change the date we've done the analysis. Actually, today's date is the 28th of May. There we go. That's updated. Change the color of it. Select there. All very quick and changes as soon as the inputs come. And you can see if you go back to the R file, hopefully, yes, sorry, this is just outputting lots of warnings, but R is working in the background invisibly and doing all of these little analyses to give you the output. And you see it's in the middle of running a function, as you can see. So there's a couple of other things to have a think about when you're building apps. First of all, we've had multiple inputs work. If you want multiple outputs from the same input, this is a slightly tricky thing to deal with, because for each output type, you have to render that output type separately. So say you have an input which is choosing the color for a graph that we've just used there. One option, of course, would be to put this input into two different functions in the server and render them separately. But it can get quite confusing and heavy as well if this is actually going to be used to filter a data set and then run an analysis on it. And then you want to output a graph and a table from that one data set. You'd have to, if you wanted to do it that way, you would create a whole set of functions that are running the whole filtering and analysis for each output. But there's one extra element which is really helpful for building an app that we're going to introduce today, and that's the reactive element. And that's putting another step in this reactive chain, which means that this is creating an intermediate reactive value called data frame, and that's also then going to update when it's been changed by the input sections of it. So the input then is used to create this reactive data frame called DF, which you can then use to run analysis and create a graph and create a table. The key thing here to note is that this is being assigned like it's becoming a function. And so every call to it has to be followed by an empty set of closed brackets afterwards. So say you want to filter a data set, you say, I want to filter by this input type. Maybe that's greater than 60 or something. This creates a reactive data frame that then this render function takes to create a graph, and this one takes to create a table, and has that same reactive flow as before. We've got one little example of that in the app here, and that's in creating the data frame as before. We want to select the comparator that we're going to do all these analyses on, and rather than do this is a very small step, but if you had lots of steps that you need to do, then you might want to use this more often. But this is going to create an intermediate data frame, an interactive data frame called df, and we see where that's passed to the plotting function, df brackets, and df brackets here as well. And finally, for the data table, df brackets here too. So that's a key thing to remember. Reactive is going to really help in making sure everything can update. If, for example, my data was going to be static, for example, if empty cars was reading from a CSV file, that could be done without using without using a reactive empty cars thing there, because it doesn't need changed. But everything that is from the user's input onwards has to be wrapped in a reactive output somehow. Jaime is going to go on and give us a little bit of how this translates into action, but I'll pause there because that is quite a few things to cover. There might be some questions about how all that works together. Some of it might be answered, of course, in